Hi folks, today we're going to work on systems of equations at the advanced level. So let's get started. Suppose we want to find the solution to the following system of equations where we actually have three variables and three equations. So we have 3x minus 2y plus 4z, 2x plus 2y minus z equals 1, and negative x minus 3y plus z equals 0. Well, in order to do this, understand that we know how to solve systems of equations with two equations and two unknowns. So that's our main objective, is to get down to two equations and two unknowns. So we can begin just like we do in other problems, trying to eliminate a variable. And the way we can do that, you can use the elimination method, or also known as the addition method, or substitution. We'll focus on substitution here. If you look at that third equation, we could solve for z pretty easily. So we get z equals x plus 3y. Now, if we make that substitution, we're down to two equations. So we want to take that third equation, substitute that into the first two equations for the z variable. And that's what you see here. So notice instead of 4z in the first equation, you have 4 times the quantity x plus 3y because we solved for z there. And in a similar manner, instead of minus z, you have minus the quantity x plus 3y. So this is a much easier thing for us to handle, and we can simplify this, and simplifying the equation on down, just distributing that 4 and that negative symbol in equations 1 and 2 respectively. You have 7x plus 10y equals negative 2, and x minus y equals 1. Well, we know how to solve this system because it's two equations and two unknowns. So all we need to do when we're looking at this question, we can get down to the x and y's. And with our first step, we just need to solve for a variable and make a substitution. In this case, we'll solve for x, so you get x equals 1 plus y. Moving on to that second step, we want to substitute in for the x in that first equation, equation 1. So 7x plus 10y equals negative 2 now becomes 7 times the quantity 1 plus y plus 10y equals negative 2. Moving forward from there, we just need to distribute that 7 to the 1 plus y. So we get 7 plus 7y plus 10y equals negative 2, and that simplifies to 17y when you combine the y terms and move that constant on over. 17y equals negative 9. Divide both sides by 17, and you're left with y equals negative 9 over 17. So now on to what we need to do from here. Well, you look at in step 1, we have x equals 1 plus y. Well, just plug in y into that equation. So you get x equals 1 plus y, which is the same as 1 plus negative 9 over 17, which is just 8 over 17. So, with that in mind, we have our x, we have our y. If you look back at our original system, up at the top, we just need to find z. So we actually had that before, if you recall. We had z equals x plus 3y when we solved for it in using our third equation, and we have x equals 8 over 17 and y equals negative 9 over 17. So z equals x plus 3y becomes 8 over 17 plus 3 times negative 9 over 17, which is negative 19 over 17. So that means the solution to the system is x equals 8 over 17, y equals negative 9 over 17, and z equals negative 19 over 17. And we can always go back, plug it in, and check the solution. But to give you a visual interpretation as to what's happening, each of these, there's actually three-dimensional drawings that we can do. And each of these equations, our top three here, are actually planes. So what happens when we actually look at this is the intersection of three planes. And the point, x equals 8 over 17, y equals negative 9 over 17, and z equals negative 19 over 17, actually occurs right here at the intersection of the green plane, the red plane, and the blue plane. Okay, so that gives us a visualization as to what's happening. And we can actually carry this on up to 4 dimensions, 5 dimensions, in terms of our number of variables. So you just try and eliminate a variable and work around from there. So moving forward, let's take a look at this next question. So we got a word problem dealing with bonds. So Eve Moneypenny has $10,000, which she wishes to invest in two types of bonds earning simple interest. The bonds have an annual interest rate of 2% and 3% respectively. If Eve wishes to earn $265 in interest every year from bonds, then how much money should Eve invest in each type of bond? And we want to find the solution to this. Well, the key is finding a good system of equations, and so that's where we begin. So we're going to let x and y denote the money invested in the bond earning 2% and 3% interest respectively. So x will be the money invested in 2% yield bond, and the y will be the 3%. So right out the gate, we know that the total invested is 10,000, so we have x plus y equals 10,000. And second, now we want to earn $265 in interest every year. So that means when we apply the amount we've invested in X times the 2% plus the amount invested in Y, that Y value times the 3%, that should equal 265. So the way we write that is 0.02x plus 0.03y equals 265. So notice we just have two equations, two unknowns. So the hardest part here is actually the setup, because now we can kind of work through the system. Well, if we want to move forward, so we have that system of equations, right? We want to make our lives easier. So first things first is screaming substitution at us. So let's solve for our y variable. Y equals 10,000 minus x. Now, we want to plug that into the second equation. That's hunky-dory when we plug it in. Notice we just replaced the y. And so we have 0.02x plus 0.03 times the quantity 10,000 minus x equals 265. But that looks like a nasty equation to solve for. However, there's a simple way to make it look a lot nicer. Anytime you see a decimal or a fraction of some sort, we can always multiply both sides of the equation to make it simpler on ourselves. And the way to make this simpler with it being a decimal is to actually multiply both sides by 100. And what we get after we multiply both sides of the equation by 100, notice we need to do that to every term, we actually get 2x plus 3 because the 0.02 times 100 is 2 and 0.03 times 100 is 3, so it makes our lives a lot simpler. And then we just have to make sure that right hand side we multiply by 100, so we get 26,500. Well, if you just distribute that 3 on through, notice you get 30,000 minus 3x, but 2x minus 3x equals negative x, so negative x plus 30,000 equals 26,500. So notice you can simplify, move that, subtract 30,000 to both sides, so you get negative 3,500, but negative x equals negative 3,500 gives us x equals 3,500. So plug this back in, we get our y value. So we go y equals 10,000 minus x, that's 10,000 minus 3,500, and that gives us 6,500. And I suggest you go back and check this, but at the end of the day, what this tells us is Eve should invest $3,500 into the bond with an annual interest rate of 2% and $6,500 into the bond with an annual interest rate of 3%, giving us our final amount that we're looking for. Okay, so last but not least, let's try and change things up. Let's assume A and B are constants. And we have the system of equations involving A and B, where A and B are just some constants. Is it even possible for us to have those combinations of constants, but have 3, 5 be a solution to the linear system of equations? So we have ax plus by equals 4, 3ax minus the quantity 2b minus 1, y equals negative 1. Is it possible for such values to exist? So a little bit different. We're actually going to flip the script a little bit and plug in 3, 5 in for the x and y. So if we plug those values in, what actually happens? Well, you get a times 3 plus b times 5, so on and so forth. But we can simplify this system. Notice that 2b minus 1, you can distribute that 5 there and move that 5 on over. So simplifying that, you get, in the first equation, 3a plus 5b equals 4. But the second equation, you'll have 9a. Notice we'll have minus 10b, but when you move that 5 on over with its other constant, 9a minus 10b equals negative 6. So now we actually have a system of equations in terms of a and b. And we can solve that system because you have two variables, two unknowns. So solving that system, what do we actually get? Well, let's use the elimination method when we're going to try and solve this system. So the first step that we want to look at is basically just multiplying that top equation. You can choose either negative 3 or positive 2. I'd say multiplying by 2 is a little easier. So we'll set it up, and then we'll multiply that top equation by 2. So when we multiply that top equation by 2, notice our b terms are going to cancel. So when we add up those equations, notice we get 15a plus 0b and then equals 2. Well, that makes our equation nice and easy to 15a equals 2. And so solving for a, we get a equals 2 over 15, and we get our final method plugging this in and figuring out our answer. So you can use either equation. I'm just going to go and use the top one. So you have 3a plus 5b equals 4. Plugging in the a, you'll get 3 times that quantity, 2 over 15, which is just The 3 and the 15 have a common factor of 3, so those can cancel out. So you're left with 2/5 there. Move that 2/5 on over, so 4 minus 2/5 is 18/5. So 5b equals 18/5. And last but not least, divide both sides by 5, and so you get b equals 18 over 25. So now we have our a, we have our b. So what's happening here? Well, we get a system of equations essentially from this. We said 3, 5 is going to be a solution. What is the system of equations that's corresponding to that? Well, a equals 2 over 15, b equals 18 over 25, and we want 3, 5 to be that solution. Well, the solution is going to be 2/15 x plus 18 over 25y equals 4, and 2/5 x minus 11 over 25y equals -1. If you want to take a look at that, what does that actually look like? Well, we have the graph right here, and as you can see, as we're hoping, our intersection point is actually at the point 3, 5.